Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on original oil in place on well basis. Okay, in previous videos we have discussed about calculating the in place for the well. Okay, so you need to differentiate between the in place of the entire reservoir and the in place connected to each well. Okay, this discussion is about in place, original oil in place connected to each well. Okay, so it's the OOIP in well basis. All right, so we will advance, we will expand the case to the case where we want to predict the current state of the drainage radius. Okay, so we will use the same formula, but we will modify a little bit. Now we want to know the drainage radius. If you already know the cumulative oil production, now what is the drainage radius? Okay, we need to know that. All right, so for that, I think I need to make a name here, merge center, and then just call it OIP, original oil in place, and make it 18 in size. Okay, and then here, want to make it here maybe, and expand it a little bit, and then drainage radius. Okay, and then I want to copy, just copy it first. I want to differentiate between the radius of the reservoir with the drainage radius, because later on you can see the difference between them. Okay, so I just call it RD for drainage radius. I want to call it, and then but yeah, maybe we can just use it for starting value. Okay, to activate other values like the area here. So I maintain the formula for the area. This is the conversion from meter squared to acre. And then let's say porosity, the same with this previous case. And let's say the initial water saturation also the same. All right. And then also for the thickness, the same. So just use equal there, and then initial volume factor, the same. So everything will be the same. All right. And then here for drainage radius, the recovery factor is not really relevant. It can be relevant, but I think you cannot say in a pure sense, in a very, strict sense, the term is recovery factor. Okay. Rather, I will call it efficiency, something like sweep efficiency, but just call it efficiency. Or maybe you can use symbol for efficiency. Usually they use, wait a minute, for efficiency, usually they use this. All right, this is to, you cannot drain all the oil perfectly on your drainage area or drainage radius or drainage area. You cannot. So if you produce from the well cannot perfectly drain all the oil from the pores right down to the residual oil saturation. Okay, there will be oil left behind on the pores. You cannot extract them perfectly until you only have residual oil saturation. So that's why I want to call it, yeah, you can call it recovery factor, you can call it efficiency, but to differentiate, to distinguish this efficiency, this drainage efficiency or sweep efficiency from the recovery factor, I just use efficiency factor here, okay? And then actually here, EUR is not really relevant. It can be relevant, but just use it later on. And then cumulative oil production here, let's say it will be known. So let's say I know that my well currently reached the cumulative oil production of 2000 mstb. Okay, at this point, I need to know the value of, okay, maybe I can put it here, the value of residual oil saturation. So now for production, to know the current drainage radius, you need to know the residual oil saturation. And let's say, just assume that the residual oil saturation is 0.2, right? Okay, from core analysis, you know that residual oil saturation is 0.2. And then it will be good if you also know the average oil saturation. Okay, just put it here. Let's say you know the average oil saturation, but I think if you don't have, proper reservoir simulation, it will be very, very difficult to predict the current oil saturation. Okay, so instead of knowing the oil saturation, the current oil saturation, I just assume efficiency factor. Okay, to know or to honor the fact that I cannot drain the oil perfectly down to residual oil saturation, I just assume efficiency factor, and the efficiency factor will represent the oil saturation whose value I don't know actually. Okay, so that's I'm going to use, and let's say the drainage or the efficiency is 70%. Okay, and so let's calculate. I'm going to expand this one. Okay, and then yep, and then just let's call it RD. Here I don't need to use my in place. Rather, I need my cumulative oil production. So here I'm going to summon, okay, and then equation, actually I'm going to use script and call it NP. All right, and another parameter that's very, very, very important here is to subtract it with residual oil saturation, actually. Okay, I'm just going to put it here. So you need to know that during production, your well cannot extract your well cannot extract the oil down to the residual oil saturation or more than the residual oil saturation. Okay, the the residual oil saturation will always be there. So the oil available for you for production is, of course, 1 minus initial water saturation minus residual oil saturation. Okay, and again, you cannot drain all the oil down to the residual oil saturation. Okay, because the drainage is not perfect. It's not perfectly efficient. So that's why here we use the drainage factor or drainage efficiency or sweep efficiency. Okay, by the way, let's use sweep efficiency here. Okay, symbol, I'm going to put the sweep efficiency there. Okay, so it's like this. To compute the drainage radius, the current drainage radius, we use this. Okay, I'm going to put it there. Actually, you can also calculate the drainage radius at the final time. And in that case, you need to replace the cumulative oil production with the EUR, estimate ultimate recovery. Okay. Okay, so now I'm going to compute. So square root, and then this one, the factor multiplied by the cumulative oil production, multiplied by the oil formation volume factor. Let's say the BOI changes very slightly. Okay, so I just use the same value for the BO here, and then divided by 7,758 multiplied by pi, multiplied by the thickness, multiplied by the porosity, and then multiplied by 1 minus initial water saturation minus residual oil saturation, and then multiplied by the sweep efficiency. And then close again, and then here we go. We have. So we just drain, so the current drainage is only 18 meters, okay? We need to check maybe, is there something wrong? And then just be careful. Cumulative oil production 2000, and then multiplied by BO here, and then divided by 7,758 by pi, and then thickness, and then multiplied by, okay, the porosity, and then here 1 minus U8, which is initial water saturation, minus residual saturation, and then multiplied by efficiency here. All right, so we make a mistake here. It should be, the NP should be multiplied by 1000 because it's in 1000 stock time barrel, whereas everything here is computed in barrel basis. So it should be multiplied by 1000, and here we go, we have the drainage radius is 570 meters. Okay, so here it's the drainage area. Okay, maybe we can use like this, subscript, also here, subscript, and then for the reservoir, subscript. Okay, so here, if you have, or if you know the porosity, you know the initial water saturation, and you need to know the residual oil saturation. Thickness, of course, formation volume factor, okay, and then, yeah, this is for the in place, okay, but let's say you know the cumulative oil production here. You know the cumulative oil production, you know the porosity, initial water saturation, residual oil saturation, thickness, formation volume factor, and let's say you also know the sweep efficiency is 70%. Now you want to know what is the drainage radius of my well, okay? What is the drainage area of my well? The drainage, the production drainage area of my well. You can use this formula to predict or to estimate the current drainage radius. Okay, so I think that's all. I hope you enjoy this video. I hope this video is useful. Thank you so much for watching, and see you again in the next Eng-Man videos. Thank you.